Anyway, I'm going to be chairing this session. I'm Erika Rybrosova, Global Technology Manager for Electronic Materials at Sun Chemical. It's great to be here. I hope you guys had a good time during the break and were able to grab some food as well as coffee and be very well alert for our next session. It's a great lineup of speakers. So let's start with UI NCS. We had a change in the speaker name here. Henrique wasn't available. So we'll have Mahmoud Tavakoli. Please come to the stage. He's the co-founder and the CTO of the company. So.
Thank you very much for the presentation, for the introduction, and welcome to this session. So today I'm going to talk about our new startup, Ewings, that I'm a co-founder, so I'm replacing Henrique, who for some personal reason wasn't able to present this. So who we are a startup based on Portugal that is a joint venture between an industry that has been 20 years serving the mobility sector, the automobile sector, and some researchers from University of Coimbra. So myself, I'm the inventor of the technology and a professor at the University of Coimbra. So when it comes to the sector of mobility, we are seeing some disruptive changes. We are seeing that the mobility sector, the automobile sector, that for some time was a bit static, and the technologies were the same because of this new concept that you see: autonomous driving, smart surfaces, e-mobility. It's changing. Everything is changing. We have surfaces that are very different from what we used to see, and what we see here more and more, we see surfaces that are clean. You don't have a lot of buttons. We want to take out all of these buttons that cost us money and processing and the plastic and everything. And instead, we have surfaces that are smart. So if we look at the textile industry and plastic industry, especially when we talk about automobile sector, the problem is that the margins are very low. So, I mean, people get an added value of 20%, 30%. But if you are able to turn this plastic and textile into a smart plastic and a smart textile, then we are able to have added values of sometimes more than 500%. So more and more you see that these traditional sectors are moving into these smart elements, and the mobility sector is also absorbing this quite well. So when it comes to printed electronics, what we observed was that usually this is the technology that many of us know. This usually performed through PCBs, flexible PCBs, and then there is a component of thermoforming. The problem though is that sometimes these substrates are too thick, and what happens is that the thermoforming, although it's able to bend a little bit, is not really adaptable to non-developable surfaces. So if you want to have like very 3D surfaces that have very interesting and attractive curves, then we are not able to do those kind of things. This is where the stretchable electronics come into the action, and we were looking also for solutions that are able to be thinner and applicable to surfaces that are more attractive and more 3D. And in addition to that, one of the things that was very interesting for us, and a lot of automobile manufacturers are interested to, are integration of electronics to the textile and to the seat. And the problem here is that, again, on the seat, we are sitting several times and applying pressure, so there is this bending and strain components, and this should be prepared to withstand this bending for thousands of times. So if you have like, let's say, changes of conductivity because of this problem, or because of just the heat that, in the summer and the winter, there are different changes of the temperature that also applies some problems on the conductivity of the ink, then we need to have a system that is very stretchable for thousands of the cycles. And we need electronics to be very thin, because we don't want to lose the ergonomic of the chair, because we want this to be very ergonomic and not feeling the electronics on the chair. So, well,